Hi guys, so in this video I'm going to walk you through some of the works I've done for the final project. So let's start with data. So for this project we have two separate cities, Singuan in Puerto Rico and Iquitos in Peru. From looking at the data, right at the beginning we know that those two cities probably should be modeled separately. One of the reasons is that if you look at the training data set, we have 936 weeks data point for Peru and 520 weeks for that's for Puerto Rico and 520 weeks for Peru. Although we have 20 climate variables in both data set, the duration of the training data set as well as the test data set, which is 260 weeks that we're supposed to project for Puerto Rico and 156 for Peru, that makes a lot of difference in model selection, in my opinion, because some of the models perform really well in the shorter duration of projections, and some models perform well when it goes to longer terms. Besides that, there's other factors out of scope of this project that I think is actually important to mention. For example, the different level of development in local population and the government support for the disease outbreaks, and also the public health and R&D support after the outbreaks. Are they doing anything to develop prevention approach for the next outbreaks? Those factors I think are very important in a time series data projection matter, because outbreaks, if you learn from the outbreaks and then you can come up with preventions for the next one, then even the climate factors are the same, the outbreaks will be much smaller. So that's just my opinion. Let's look at the EDA. So what I did was really simple. I plot both cities with the ACF and PACF plots. So very interesting that for both cities, we have really, really high autocorrelation. So I'm thinking about for if I were using ARIMA models, this ER term would have to be more than 5. So 5, 6, 7, 8, I don't know how high I can go. It seems like 10 is a cap, but I think 10 or even 15 for Puerto Rico, but I think that's a little bit too high for the model to run. And besides that, if we look at the raw plot here, for the very, very big outbreaks, Puerto Rico has a cycle of 200 weeks, if you count it 200, 200, 200. Whereas for Peru, we have about 100 weeks as a cycle, so 100, 100, roughly. And for this data set, we have quite a bit of missing data for a lot of variables. So the way I did my imputation was to take the last observed value. Because this is time series data set, so I think taking the last observed value makes the most sense. And I don't know if everyone still remembers how we did the midterms, that actually zero inflated distribution works better. So in this project, I did the plots separating the zero cases versus non-zero cases, as well as the total cases. So as you can see that Puerto Rico has only 0.04% zero cases in the training data set, whereas Iquitos has 18%. So at this point, I would go, my first round of model probably will go with negative binomial for Singuan and binomial plus gamma distribution for Iquitos, or zero inflated negative binomial. So next one is variable selection. For both cities, we have exactly the same climate variables, which can be put into 3 categories, so temperature, humidity, and rainwaters. And when you look at this correlation matrix, it's really like a mess. None of the variables are really correlated with our target variables. I know this really small picture, but the last row is the total cases. So you see it's really light. neither positive correlated nor negative correlated, which is a little bit disappointing. I don't know how the model is going to go. Besides that, a lot of variables are very highly correlated within themselves, and even that some of them are identical. You see that one appears twice, that means one variable is perfectly correlated with the other. So that's something we need to consider when we pick the variables for modeling. And there's other things that I think is very important for this project, that we need to understand how the disease actually develops. So for example, after reading a few medical papers online, I felt there's at least two involvements for lagging variables. One is on the mosquito development. So this disease is transmitted by mosquito. Mosquito's life cycle is about 2 to 4 weeks. So an environmental variable that gives mosquito the best condition to live will probably correlate it stronger with the total cases at outbreaks of the disease. So that's one lag variable. And the other one is the transmission time. So the temperature will build up to accumulatively create this optimal environment for disease to outbreak. So I think in order to accurately predict all those very, very high, big outbreaks, high peak, cumulative environmental variable conditions are essential as well. When it comes to model selection, for me, I'd like to start with simple models. Oh, that's a typo. So I started with 4 to 8 different variables for each of the 3 categories for the 2 cities. And I also include some lag variables, as I mentioned, that to account mosquito development and cumulative best condition for transmission. So I fitted negative binomial on the Puerto Rico city and binomial plus gamma on the Peru. And I also tried out fitting ARIMA on the residue of the model. And I tried out with XREX and without XREX. And based on the performance, the one with XREX performed slightly better. I also tried out fitting the ARIMA with XREX on both cities directly. The performance is okay, not as good as negative binomial in my case. And I also fitted neural network on both cities. So lastly, I'm just gonna show you some of the performance plot. So this one's interesting. So if you look at this fitting part, so I split the data set for Xinran into 800 weeks and 136 weeks as train and test data set for myself to see how my model performs. So if you look at this plot, if you focus on the fitted value part, clearly binomial gamma distribution performs much better than the negative binomial plus ARIMA. However, if you look at the forecast part, which is circled by red, the negative binomial doesn't perform that bad. And in fact, the MAE performance metrics show me they're actually similar. So this is something interesting that I found during my work of the final projects. As to the out of sample scoring on the submission, I'm still working on it. And I look at the forecast of all the 3 models or 4 models I've fitted so far. Actually, none of them performs really well, that well. And based on the comparison versus the score I get from the website, I kind of have a new idea that I want to try. I don't know how it's going to go. I guess we'll just have to see. I think that's it.